Hey, Ag Teacher Thoughts here, coming at you with another video, and this one is where we are working on renewables. So we're working on renewable fuels. It's part of what we deal in ag, or in my ag classes, because a lot of our renewable fuels are produced through agricultural means. But we have one of them that I'm going to feature here that doesn't really come through ag, but it is an interesting one nonetheless. And because we're looking at all of the others, we cover this one too. So this one here, I'll show you a little bit about what's going on. We have a little bit of electrolysis going on here. So we have a special piece of lab equipment that has an electrolyte in there that we're running, and then it's hooked up to a power supply. And right now we are pushing 20 volts in there. And then that electricity runs down into our electrodes down here. And these electrodes are actually made out of platinum. So that's one of the few materials that we can use for an electrode that's not going to be consumed as a part of this process, or at least it's very, very hard to get it to be consumed. So they are bubbling away, and over here, see on the left, we have some bubbles going, and on the right, we have some bubbles going. And this is our spare electrolyte down here. So we do have to add something to the water to help in the electrolysis process. And what we are running right now is currently baking soda. I have tried other electrolytes, and if you use other common electrolytes, you can actually run yourself into some problems. I was working on writing a curricula with a large natural gas producer. So I was working with an environmental group on behalf of a large natural gas provider in a place where I used to work. Not going to give you all the names. I'm not going to name drop here on that, but I was hired as a fellow to help write the curricula. And so I experimented with hydrogen production, and I used different types of electrodes. So I used electrodes that were aluminum, ones that were graphite, ones that were steel, ones that were copper, and I just experimented with all sorts of different electrodes, so these little pieces in here. I didn't have platinum, so I couldn't do that. And then, you know, I was writing labs that went with that. And then I wanted to work through different types of electrolytes. So I selected materials that produce electrolytes in the water. So I got some things for that. I tried hydrochloric acid. Don't do that one. I tried table salt. Don't do that one. And then finally I settled on baking soda. So the reason we don't use hydrochloric acid or table salt in the electrolysis process is the electrolysis process will actually break down our electrolyte, and it will free up the materials that is composed of. So as a part of the electrolysis with hydrochloric acid, you're releasing hydrogen, and you're releasing hydrogen and oxygen in your process, but you're also releasing the other part, which is chlorine gas. And you also do the same thing when you break up table salt, which is sodium chloride. So both of those produced chlorine gas, and in quantities that was uncomfortable, we'll put it that way. So yeah, definitely didn't want to do that. So that's why I settled on the baking soda. And that baking soda is a much, much better option. Now up here, I will tell you that each of our electrodes, depending on whether you have a positive or a negative electrode, you have different gases that build up here. So if we look up here, our level of our gas is right here. And if we move across over here, this has been running for a little bit, our level of our gas on here is right here. So one is short and one is tall. And the whole point is to figure out which is oxygen and which is hydrogen. So what we have down here to help with this lab is we have a container of water with a little bit of soap in it. And what we're going to do is we're going to come up and we're going to open this valve up here, and it should bubble up some of our gas, and then it's captured. Our gas is captured down here in the bubbles. And then to prove that we know which one we've got, we can light it on fire. Those pops that you heard were the hydrogen gas igniting. So the larger volume that was over here was the hydrogen, and the smaller volume that we have over here is the oxygen. So the oxygen, if we were to let that go, it will bubble up. It'll just make the flame brighter. It helps with that, but it doesn't pop like the hydrogen does. But this is our electrolysis lab for splitting hydrogen and oxygen. And we split that out of water. Now, when you're doing hydrogen production for commercial hydrogen production for fuel, one of the other things that you do need to know is the most common source of hydrogen, it isn't water. A lot of your commercial hydrogen that you get out there is actually split off of a hydrocarbon. In other words, a petroleum product. Most frequently, gasoline. So though you may think that your hydrogen-powered car is green, unless it's done with electrolysis, it's still using gasoline. They're just stripping the hydrogen molecules off of the gasoline molecule and then taking that gas and compressing it, and then you're going to use it. So this one here, the reason why we talk about electrolysis is this one can be used in combination with a lot of the other renewables, such as wind power and solar. Because you can take that when you've got excess wind and solar, you can generate hydrogen gas, which can then be compressed and used later. Since our electrical grid has no capacitance to it, it has no capacity to store. So that's why we cover this one, is it's a kind of a storage solution for us for some of our renewables. But anyway, I'll let you look a few more moments at the bubbles. So there is your hydrogen. There is your oxygen. And there they are together. And we'll see if we can bubble up just a little bit more. I think we got just a few more bubbles. And then we'll light it on fire. There you go. Anyway, I hope you learned something today. Ag Teacher Thoughts out.